Okay, I have this pressurized water reactor simulator slash game that I'm creating in Unity, and here I have the reactor, I have the pressurizer, I have the steam generator, I have the reactor coolant pumps, and of course the pipes in between the various components. I have all the data next to all the items that you can see here. Right now I'm in a steady state, and I'm going to go ahead. Let's say I want to raise reactor coolant temperature. I can go into the reactor here. I don't have any of the items uh, modifiable via the game window here. I'm just doing everything via the Unity inspector. So I'm going to raise the control rods up a little bit to 62. You can see that the temperature goes up, the outlet temperature of the reactor. The flow is going this way from the reactor to the steam generator through the pump and then back to the reactor. I have a simulated load here on the steam generator of 1,000 megawatts, and you can see that as I had raised the control rods up a little bit, it increased the output of the reactor, increased the temperature. Let me go ahead and go to the steam generator and see if I can raise the load up a little bit. Let me raise that up to 1027. That's fine. You can see that affects the differential temperature across the steam generator, the delta T, and everything's increasing, or I'm sorry, lowering here. And you can see that the power of the reactor actually follows the load of the steam generator. It takes a little time, but it does get there. Everything is happening here much faster than it would in a real reactor coolant loop. I can what else can I do? I have on the pressurizer. I can turn the heater on, for example, and you'll start seeing the pressure rise here, starting to go up. Let me turn that off, and it'll start to slow down. And of course, I can turn the spray on, and you'll start seeing it go down, the pressure. And the actual reactor coolant pump itself, where is it? Here we go. Let me just raise the pump speed up a little bit. The delta T across things decrease. Again, everything's happening really, really quick here, as opposed to a real world situation here. This has a negative temperature coefficient, so the reactor coolant, as temperature goes up, reactor coolant reactivity, or the reactivity goes down. Yeah, so this is just a basic simulation. I wanted to try to create